Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to Technical Session 3A. Myself, Ishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th of February 2024, and the virtual event is being held through Zoom today and tomorrow, that is 21st and 22nd February 2024. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we'll have 6 presentations. Each presenter will be given 12 minutes for the presentation and 2 minutes for question and answer. On 10 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair for this session. We have with us our session chair, Dr. Neha Tiwari, who is working as an associate professor and additional head in Department of Computer Science and IT at IIS, deemed to be University Jaipur. She's a research supervisor with an experience of more than 16 years and has also supervised the students in a variety of projects. Her research domains include networking, machine learning, blockchain, databases, software engineering, and cloud computing. We welcome you, ma'am.
Thank you so much, Ishita.
Thank you, ma'am. We have with us our second chair, Dr. S.M. Hassan Mahmood, who has received a PhD degree in computer science and technology from the University of Electronic Science and Technology of China. He's working with us as an assistant professor with the Department of Computer Science, American International University, Bangladesh. His research interests include machine learning, deep learning, bioinformatics, drug discovery, and pattern recognition. We welcome you, sir. We'll be beginning with our paper presentations. I'd like to invite our first presenter for the session, Saud, with the paper titled "A Transformer and Federated Learning Techniques for Detecting DDoS Attacks in IoT Environments." You may start with the presentation.
Thank you. Good afternoon, everyone. I would like to extend our welcome to all attendees. My name is Saud Al-Ayed, and my colleague, the second author, Saad Al-Ahmadi. I am honored to have the opportunity to present our paper titled "A Transformer and Federated Learning Techniques for Detecting DDoS Attacks in IoT Environments." Thank you for joining us today as we explore the innovative approaches and findings outlined in this research. Today, we will cover introduction, then literature review, after that proposed methodology, type transformer based on federated learning, TTFL, finally experiment evaluation. Our motivations, the first motivation, rising importance of IoT, which need security mechanisms to protect these IoT devices and networks. Second motivation, cyber attacks on IoT, especially DDoS attacks, have become more advanced and widespread, which necessitating advanced detection mechanisms. Intrusion detection system is essential to mitigate the risks of DDoS attacks. And one of our motivations, the limitations of IoT devices such as memory and energy require special techniques to protect these devices. After in-depth research, we found that machine learning and federated learning are contributes to protect IT devices by providing new techniques for intrusion detection system. So we look to produce new technique that combines transformer and federated learning. In the literature review stage, we divided the studies into several sections. The first section is machine learning-based approaches. Second section, deep learning-based approaches. Third one, combination of machine learning and deep learning, and federated learning-based approaches. To save the time, I will show our observations for literature for literature review. The first observation, traditional methods of intrusion detection are evolving towards more sophisticated techniques. The second observation, machine learning, deep learning, and federated learning are emerging as powerful tools in addressing security challenges in IoT networks. Our methodology, TTFL, we employing a classification method based on type transformer to detect attacks in just a moment, I will remove this. Sorry for that. We employing a classification method based on a type transformer to detect and classify network traffic in IoT environments. We used attention techniques in type transformer network architecture to train data on large scale. And then we utilized federated learning techniques on transformer model. After that, we optimized the proposed models hyperparameters. Finally, we validate performance of the proposed system. Advantage of TTFL. The first advantage is a novel intrusion detection system architecture. We proposed innovative IDS based on deep learning techniques, and we utilized transformer technology with federated learning for enhanced accuracy and efficiency. And we utilize contemporary and large-scale data sets. We use the Tone IoT, CICD DAS 2019, and LATAM DDoS IoT. In our evaluation process, we carefully analyzed various performance metrics to gauge the effectiveness of our model. We used accuracy, precision, recall, and F1 score. To ensure rigorous experimentation and result reliability, we repeated experiment 10 times for robust results. We calculated means and 95% confidence intervals for result reliability. And we compared the average performance of our model with the best results obtained by contemporary methods. A structural model. Type transformer is a deep learning model specifically designed for processing tabular data. So the type transformer model architecture contains several layers. We have the first one, input encoding, then column embedding layer. After that, the main or the most important and the core of the type transformer encoder layer, which consists of the multi-head attention and feed forward neural network, which help to capture non-linear dependencies between or within the data. After that, we have the concatenation layer, then MLB layer, and then loss layer. And in loss layer, we use the binary cross entropy loss function. And finally, output layer, we employ the sigmoid activation function. As we can see here, the figure illustration the learning process in transformer model for the DDoS detection in IoT using federated learning. The federated learning workflow involves server and in clients sharing computations across multiple federated learning rounds, and the data set is shared between them. The process begins with the initialization, where the server generates random weights for the top transformer model. Next, weights are transmitted to all participating clients. Each client independently trains its top transformer model using assigned data. As a result, as a result, each client produce local model updates. These updates are then communicated back to the server. The server averages the received weights to create a global model. Subsequently, the server tests the global model with its own data. Update weights from the global model are transmitted back to all clients. Each client now enhances its local model with these updates. This iterative process continues until convergence reaching the predetermined number of federated learning rounds. As we know, the importance of data pre-processing in quality and effectiveness of model. So we exclusion of specific features. We employed RFE for feature selection. We handling categorical features. We applied downsampling balancing techniques. Then we handling unique categorical feature values. And finally, we used imputation to handle missing values. Now, we'll show our results for using the first dataset we used in our research. The first dataset, CICD DAS 2019. As we can see in the figure, our model TTFL, which by the green label, achieved the highest record or performance between other models. We achieved 99.91% for accuracy, which considered the highest between other models. And we achieved in precision 99.97%. And for recall, we achieved 99.85%. Which also considered the highest between the other models. And finally, in F1 score, we achieved 99.91%. And these results achieved by using the next hyperparameters, 10 global epochs, 3 clients, 4 transformer blocks, 4 multi-head attention heads, and 3 MLB. Using Tune IoT dataset, we also achieve the highest records between other models. We achieved for accuracy 99.62%, for precision 99.68%, for recall 99.56%, and for F1 score 99.62%. And we consider the highest between the other experiments or the other models. And we're using the following hyperparameters. In the third one, LATAM DDoS IoT, we achieved also, or we need to note one important thing. At the time we make the experiments, there was just one study use this dataset, so that we don't have many models, so that we make a new experiment. We use CNN based on federated learning. And compare it with our proposed model TTFL, and we achieved highest accuracy 99.11%, for precision 99.69%, which outperform all other models except MLB. And for recall, we achieved 98.98% for if one score 99.33%, and consider the highest between other models. Thank you, and time for your questions.
Okay, Mr. Saud, the presentation was good. I must congratulate you on that. Can you
Thank you.
hear me?
Thank you.
Yeah. So my question to you is, can you just brief me about the components of your network? How many devices you added? How many IoT devices you considered? What was the size with the structure of the network?
Actually, we didn't use we used Google Colab and make it as one device. We just this model contains all the federated learning, so that it's just one device. And for every experiment, we make different clients. As in LATAM, we use 5 clients, and for tone, we used also 5 clients, and for CIC DDoS 2019, 3 clients. And we can see that we make many of experiments, and we found that the best number of hyperparameters for federated learning clients, which in this slides.
Okay, so do you think that with this less number of clients and keeping the dynamicity of IoT devices, if you increase it, does it will it impact your work? Will it impact the functionality or the response of the algorithm?
Actually, during the experiments, we noticed that sometimes when increase the number of clients, the accuracy or the performance, no difference. Also, sometimes it's go down the experiments, so that I don't think the number of clients will increase the performance.
No, but that is, something which is always taken into account, and it's something which is known to everyone, right?
Yeah.
When we specifically talk about IoT devices, so their dynamicity usually impact the performance of the system, right? This is not an assumption. This is a truth which we all know. So keeping that in mind, I was asking that, did you try doing that and, identifying the impact of it on your work, or you have not considered it as at all?
Actually, Doctor, this first time I make like this research, so that I will keep these points in my mind for the next inshallah work. But for now, this first time I make like this work. So
Okay. And what are your future plans? How do you think this work can be further extended?
I'm looking to apply this idea for fog computing, and make a cluster of IoT devices connected to gateway, and the gateway work as client. And many clients or many clusters will be connected for the cloud, and the cloud will be the server or the main client for federated learning. This is my planning for next inshallah work.
All right. Thank you so much.
Thank you, Doctor.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our next presenter. I'd like to invite Sneha Pukharkar to present the paper titled Balancing Autonomy, Resource Management, and Internship Integration, Challenges and Strategies in Hybrid Learning. You may start with your presentation, ma'am. Paper presenter, Sneha.
Good evening, everyone.
Hmm.
Actually, there may be afternoon there. So, I'm Dr. Sneha Pokharkar from MIT Academy of Engineering, Pune, Maharashtra, India. And now I'm going to present a paper on balancing autonomy. Just I will share my presentation.
Sure, ma'am.
Okay, so I'm presenting a paper on balancing autonomy, research management, and internship integration, challenges and strategies in hybrid learning. Along with me, Dr. Deepti Sakhre, Ashutosh Chavan, and Dr. Mahesh Gaudar are co-author for this particular paper, and I am Dr. Sneha Pokharkar going to present this paper. So, autonomous colleges aim for a significant revolution in higher education. And these colleges have some innovation methods while governing or decision making, and they offer some unique traits. Means they can be distinguished from typical colleges by the variety of unique traits. To mention few, their ability to design and modify their own courses in response to the scientific and commercial development sets them apart. Then they can offer cutting edge programs, and because of that many times the versatility they have versatility, and they have partnership with the businesses, many of the research institutions or in other universities, and this expands the range of educational opportunities for students as well. Autonomous institutions have advantage of being able to swiftly modify their curriculum to take account of market technology and advancement. Because of this, students get teaching that is relevant and up to date instead of the regular university colleges, and this increases their chances of finding employment after graduation. The another method is this swift curriculum adjustment incorporate to the market trends, that is okay, and along with that diverse assessment methods they can opt, and like project based assessment, presentations, and industry internships. Autonomous institutions provide students with a more holistic learning experience, and because of this knowledge application through practice, means they give knowledge application through practice rather than normally memorizing techniques. So these are the this was the basic introduction why we are starting writing this paper, and the background behind that our institute, MIT Academy of Engineering, we are autonomous, and when we offer many advantages such as flexibility, then course then different grading methods, and maintain consistent educational standards across the across different schools. And they are, when we are offering autonomy, we have to manage so many things, and those things are nothing but managing infrastructures, then managing research project, selection of research project, find out different public relationship opportunities for the students as well as to engage the faculties into this field. And for all this, to manage all these things, we means each autonomous institute needs more and more financial and administrative resources or support, we can say. And particularly for new or smaller organization, many times they find it very difficult. So increased autonomy in decision making and governance may result in administrative issues and conflict. So here we are going to highlight the importance of establishing efficient resource allocation and governance system to maintain educational quality. For this particular paper, for writing this particular paper, we have considered one case study of our institute itself. So, however, autonomous institutes are having so many advantages, but there are certain challenges also. So the first challenges is, like we can say, the resource allocation and infrastructure. So in this challenge, the skill labs, many of the autonomous institutes, they offer practical knowledge more compared to the theory. And to develop that, they have skill labs associated with it. So skill labs need specific resources and infrastructures. Particularly, those are involved in hands-on practice. So they need some specialized equipment. And it becomes very difficult task to provide hands-on to provide this instrument to each and every student. Many times the tasks are carried out in a group itself. The second is curriculum coordination and faculty expertise. So in order to offer a variety of electives and honor courses, it is necessary for several departments and faculty members to work together. So many times multidisciplinary approach is selected, they come together and they form a group, and they try, this group of expert faculties try to deliver the content. But when we are managing when these things are carried out, particularly, it might be difficult to make sure that the curriculum is coherent, or to avoid duplication, or to adhere the institution's general rules. And then so institution needs planning beforehand to achieve all these activities. The third challenge in balancing autonomy is students' interest and enrollment. Many times when particular elective, they are offering more and more job opportunities, students are selecting the particular course. Means student interest and enrollment, this is a crucial factor in the success of honor courses. Few honor courses are not selected by any of the student, and few courses the students, means many times institution has to stop enrollment for a particular course, departmental electives or for open electives. So it might be challenging to strike a balance between course supply and demand from the students, we can say. So a course that is oversubscribed can put a strain on the resources, and many times we have to restrict the access for the students. Whereas a course that is unsubscribed, or that is not usually liked by the students, can result in the resource waste. Means many of the institutions have faced the challenge that they have to run a particular subject, particular course only for 4 to 5 students. So to offer a diverse and interesting variety of the courses, institutions need to periodically examine and predict students' preferences. Then the fourth challenge faced by this autonomous organization is academic regulations and logistics. Means managing an array of elective courses might provide logistical, scheduling, and credit allocation difficulties. So clear academic rules clear academic rules that specify credit hours, then evaluation criteria, prerequisite for each course. This is needed by the institution. And establishing a productive method to control enrollment, monitor development, and guarantee that students satisfy the prerequisite for the elective and honor is become very, very crucial. And the last but the most important challenge is quality assurance. It might be difficult to maintain a high standard of quality across these electives, honors, and skill labs. So continuous monitoring and assessments are needed to make sure that each course adheres to the academic requirement of the institution. They uses efficient teaching techniques and offer worldwide learning opportunities. So this becomes more crucial as the selection of courses grows, and making the quality assurance a difficult and a constant task for the institution. For that, many times quality checks are offered, or certain committees are established. Those committees are controlled by management people to see whether this quality is maintained specifically or not. Then the next, so these were the challenges faced by autonomous institutes. But as we are talking about, the autonomous institutions offer a very good thing that they are offering internship along with the academics. But many times, balancing this internship along with the academics becomes a difficult task, not only for the teachers, but also for the students also. Mainly, there are 5 challenges which I thought I should share with you all. That first of all, maintaining the academic continuity, maintaining the academic continuity. Many times, students are attending college, attending sessions, and along with that, they are working in the companies, completing their internship. So it becomes difficult for them to attend all the lectures, to submit assignments on time, and many things. Then providing necessary support. Every time they are not able to attend the practicals, so they need supports in many ways, with respect to write-ups, with respect to executions, or some continuous assessment, some internal assessments for that. Equitable learning experience. This becomes difficult for them to get the learning experience throughout or 100%. Then assessment alignments. Uh, Many students are facing this thing. This is a critical time of our company, that March end, and at the same time, the exams are offered. So how we can manage between these two? Or continuous assessment are mostly scheduled in the peak working hours, so we are not able to submit it. So these kind of issues they have to balance. And the last one is logistical complexity, that to manage all the things by resource person as well as by the learner, that becomes difficult part. So mainly, these are the challenges balancing internship with the academics. So to find out different ways out for this, 1 year we just observed what are the challenges we are facing, what is the feedback of students, and then we worked on the some solutions for this. So the first solution was the common slots for open electives. So each and every student, they are finding to avoid the overlaps, and to get each and every student to get the same right. Okay, anyway, all the slots in the institution will be work some same time for the open electives. So for this, the timetable was designed such that open elective slots, so this is the timetable for third year and this is the timetable for final year. So all the open elective slot will be at the same time throughout the institutions, so that faculty management as well as students becomes an easy task. Then the second way out was the classification of lab sessions. Lab sessions are classified in such a way that many of the lab sessions were scheduled after the hours. Means few of the faculties were having staggered time. Means they were joining the college
Excuse me,
late.
Prasanna. I'm really sorry to disturb you, but this is a time reminder.
Okay, yes.
Uh,
So the classification of lab sessions are such that many of the slots were late evening or early morning. Then for students should opt more and more honor courses. For that, the honor courses are reserved a special place, and mostly on the Saturdays, so that the students who are opting for the internship, they will able to attend those theory sessions. The next was integration of information and communication technology, that is ICT. For this, we used Moodle courses, so that if the student is not attending the courses, they will able to access the material at least. The next was real-time engagement through hybrid sessions. Few sessions were arranged on the weekends for their doubt solving. Morning slots were specifically designed for the theory sessions. Like this, in the timetable, you can see many of the theory sessions were scheduled in the morning, because usually company starts after 10, so they will able to attend the theory sessions in hybrid mode. And for hybrid mode, we were conducting sessions online as well as in offline mode, in both the ways at the same time. So these were the way out thereof. And after that, to observe the effectiveness of this case study, few feedback is taken from the few students, that is it helping them. So from the result, you can see that many of the students were happy with this with this case study that yes, the hybrid mode, and along with that, when you are managing theory sessions as well as practical, this becomes easy for them. Then weekly planned offline doubt solving session were helpful for the students. Study material access was helpful for the students, and the recorded session they can use later on. So this was the case study, and based on that, now the timetable was designed from these studies. So conclusion from this is, though autonomous colleges have many advantages, but they have to face many challenges also, like standard maintenance, resource management, decision making process, and also if there is an internship like year-long internship or semester-long internship, then for that planning and flexibility is required, ensuring academic integrity and equitable learning experience by both learners as well as by the students. And by changing some assessment methods also, we can go with the successful implementation of balancing all these tasks together. These are the references for my this case study and for this work. Thank you. Thank you so much. So any questions or this?
Okay, so my question to you, Dr. Sneha, would be, I think you you hold a doctorate degree already, isn't it?
Yes, ma'am.
Okay. So whenever we present something like a paper in a conference, we look up to some kind of research innovation, right?
Yes.
And in that, researching means we drill down into whatever is there already, and people have, their views, they've proven something. We review the proven facts, right? And then we perform a review of it. We
Yes, ma'am.
either re-establish it or we contribute something new to it. I would like to highlight that ours was a college, and then it turned out to be an autonomous, and then it's deemed to be university now. So whatever challenges you've highlighted, they have not been established somewhere. This is something which we have, found out, and we are presenting it here, right? And similarly, whatever solutions that you've provided have already been implemented by us. We've been like doing it for years now. So, presenting the, I would say, some kind of situation which you're facing at your work front, and highlighting the challenges of it, and presenting the solutions for it. Do you really think this can be a part of some kind of research work that we have done?
No, ma'am. It was not a research work. But when I saw this conference, there was a certain area, specific area was here regarding this, what we can say, assessment methods or teaching or practices. So I thought to share my experience, case studies here for this particular conference, because I saw some ICT enabled field was there for the particular conference.
Yes, I got your point. So, but in that case, I would say you need to look out for certain challenges that work as a matrix, that work as standards somewhere. So, if we take that, it gives a kind of authentication to our work. That whatever we have presented has some solid background with it. So
Right.
it adds some weight to your work. So
Yes.
I would say, if you do that, if you add that element in your presentation, it will be more impactful.
Sure, ma'am.
Thank you
I
so
will do
much.
that.
Yeah.
Thank you.
Good luck. Yeah.
Thank you for the suggestion. Thank you, ma'am.
Sir Hassan Mahmood, would you like to ask any question? It seems he's.
Sorry, no question from my side.
Okay, sir. Okay.
Okay, thank you.
Thank you.
Thank you, everyone.
We'll be proceeding with our next presenter. I'd like to invite Utkarsh Singh with the paper titled Battery Temperature Forecasting Method, Li-ion Battery Case Study. You may start with the presentation. Sir Utkarsh?
Yeah, Ishita, one sec. Ishita, is it okay if we proceed with the next presentation and I go after them?
Yeah, sure, no issues.
Thanks, thank you.
We will be proceeding with our next presenter. I'd like to invite Sir Carlos to present the paper titled Bibliometric Analysis of the Use of Technology in Neuropsychology. So if you're ready, then you can start your presentation. Sir Carlos? Seems he's not there yet. Proceeding with the next presenter. Sir Rasen with the paper titled Distributed Deep Learning Based Model for Financial Fraud Detection and Supply Chain Networks. If you're ready, then you can start your presentation. Seems we do not have him. Okay. Ma'am Neha, we have a few presenters from the previous session who were not able to present. We'll take them.
But what if, in case the designated people turn up and we exceed the duration of the meeting?
Since we do not have three presenters right now, and Utkarsh will be presenting.
Can I try again?
Yeah, yeah, please go ahead.
Is my screen visible now?
It is visible. Please go ahead.
Okay. So good afternoon, everybody. I extend my sincere greetings to everybody on this call. So I'm Utkarsh and I'm a software engineer. So me and my fellow classmates, Vidushi, Anustav, and Madhav, we had pursued this study during our final semester of engineering under the guidance of our director of academics in MIT World Peace University, which is in Pune, Dr. Arthi Kapade. Unfortunately, they could not join us today, so I'll be presenting this paper myself. So our paper titled Battery Temperature Forecasting Methods is a case study specific to lithium-ion batteries. So we explored the implementation of time series forecasting models on lithium-ion batteries for forecasting the temperature of these batteries when there is little to no prior information about the other characteristics of the battery. So this will be the agenda that I'll be covering. So the motivation for this study, we have derived our implementation from the knowledge that, so basically in today's world, what happens that the storage administrators, right? So in the various industries in the storage domain, so they have to continuously monitor their storage, the storage of their systems. So what they do is that they have to be able to efficiently forecast what the future capacity trends of their storage systems will be in order to efficiently manage workloads for their customers. So similar to capacity forecasting in storage systems, we thought that maybe we could replicate something similar to batteries with respect to forecasting the temperature, because it too is essential in effectively managing the battery health overall during the lifespan of the battery, right? So we have tried to replicate that approach in storage systems to forecast the temperature of these batteries using time series models. So the significance of the study, so accurate temperature forecasting aids in maintaining the optimal operational conditions, preventing thermal runaway and extending the battery lifespan. If we're able to predetermine the temperature of the battery based on the trends that we have seen, it would be good for the person handling these batteries to know, okay, that we are going to reach the threshold point before it breaks down, right? So real-time temperature tracking during the operational profile. So a battery typically has three operational profiles: charge, discharge, and impedance. In this study, we'll discover the battery trends during the charging phase of the battery, and it will help to detect the anomalies and observe temperature trends. So, and the objectives of the study are clear. So we want to generalize a forecasting model for each battery type, right? So two battery types may not necessarily behave the same way. So for each battery type, we have tried to determine a forecasting model based on its own characteristics and based on its own historical data of the trends or patterns that it has observed, right? So literature review. So these are two of the papers that we have referred, which has helped us in our foundation. So a dynamic state of health forecasting model for electric trucks. So this paper establishes that the findings establish that ARIMA model, which is one of the time series forecasting models, could be a valuable tool for battery health management, particularly in industry settings where limited information about the batteries is a very common occurrence. And the second paper, which also helps establish our fundamentals, it suggests that the time series methods for battery temperature can be a promising approach with respect to forecasting. So that's the foundation that we try to reestablish and further provide to it. So the data set that we have, right? So this data set we got from the Center of Advanced Life Cycle Engineering, where it was uploaded by a manufacturer for 34 different battery types for lithium ion. Okay. And so the processing that we have done on the battery, right? A high level overview for what we have done on it. So we have efficiently dealt with the null values that are there, which may be due to faulty measurements while reading those temperatures of the battery. And since this is time series data, right, the granularity of the data that we have is of 6 seconds. So basically every 6 seconds, we have a reading of that lithium ion battery type's temperature. So we have tried to analyze the correlation between different features with respect to our target variable, that is temperature, and see if any strong correlation existed to the temperature measured. So we tried to find the correlation and for our multivariate forecasting. And based on that, we found that current charge could be another parameter which we could consider. And we've split our data into 80-20% ratio, 20% for validation. And then we resampled the data for the metrics that concern us, basically. So the data that we have, right, as I mentioned, we have data of 34 unique batteries, and per battery, we have at least 80 files. And for each of those 80 files, we have these three different fields, right, for impedance, for discharge, and for charge. And within each, so I'll go for charging fields because this is that we have tried to forecast behavior of the battery during charging. So these were the different fields in the charging domain of the file. So basically 34 unique batteries, lithium ion batteries. Per battery, we have at least 80 files. And per file, these are the fields that concern us, right? So the framework, so basically the models we have implemented, right? So the reasoning for selecting ARIMA and LSTM. So for all the batteries that we tested, that we had data of, right? We could not find inherent seasonality in the data. So that excludes, or that makes us confirm that we can avoid the models which are good with handling seasonality in the data. So there are other forecasting models like Profit, there's Holt-Kluwer's method, and there's Sarimax model, which are good models in taking into consideration the seasonality of the data. But since the data which we have analyzed does not have seasonality, we have gone with classical ARIMA model and the LSTM model as well, which is a type of recurrent neural network. So basically a quick overview of what ARIMA is, right? So ARIMA basically is an autoregressive integrated moving average model. So basically autoregressive means here is that it takes into consideration the values at the previous time steps for making the forecasts. And integrated here means that we try to take the difference of the data if it's non-stationary. So assumption of ARIMA model is that the data we have is non-stationary. What that means is that the value of the temperature at the current time step is independent of the values at the previous time step. So these are the two models that we have tried to explore, ARIMA and LSTM. And within LSTM, we have tried univariate LSTM as well as multivariate LSTM. So univariate LSTM, as the name implies, means only one independent variable, which is time itself. And multivariate LSTM, we have considered the other other metric, which we found has a strong correlation for making the forecasts. So as I mentioned, so for ARIMA, we need three values, the PDQ values, and how to determine these values. So the best value would be the ones which have the least ICICT information criterion, which is a evaluation metric for ARIMA models. So in spite of that as well, we've also manually validated that these PDQ values for the ARIMA model are actually the best fit values for making the forecasts by plotting different graphs and seeing that, okay, that eventually at this XYZ PDQ value, the model has the least ICICT information criterion, that is the AIC value. And for LSTM model, we have trained the model on three LSTM layers followed by a dense layer. And for each LSTM layer, we have followed it by a dropout layer. So the implementation, so I'll take you to so this is a brief overview of the proposed methodology that we suggest could be implemented in predicting the temperature of the batteries, right? So we have the time series data of the battery. Is it stationary or not? If it is stationary, then we go ahead. If it's not stationary, then we difference the time series until the seasonality has been removed in the data, right? So basically stationarity is when over time, the mean and the variance of the data are constant over time. To remove that, we do differencing so that it fits the time series model, that is ARIMA, well, because it works on non-seasonal data. So we go ahead, if the data, once we get the data to be stationary, we plot the ACF and PACF graphs, which are nothing but graphs which give us the P and Q values for the ARIMA model. We validate those metrics using the ICICT information criterion. We fit the ARIMA model, we validate the model on the test set, and we get the RMSE for the ARIMA model. So this is done for each battery type. Similarly, we also do the same thing implementing the LSTM model. So if the data we have is univariate, we go ahead. If it is not univariate, so that would imply that the data that we have passed to the model is the multivariate model. That is, it has more independent variables, and which, as I mentioned, will be time and voltage, and the target variable would be temperature. So thumb rule in LSTM is to consider the window size. That is, LSTM works on sequential data, right? So the sequential data width or length, what should that be? So a rule of thumb is it should be greater than equal to one seasonality period. So we have gone with that thumb rule. And then we train the model using that sequential data that we have based on the window size from the previous step. We fit the LSTM model, validate the model, and get the RMSE value for LSTM. And then we compare these RMSE values. And whichever model gives the least RMSE would be the best fit for that battery type. And then we can recommend that, okay, for this battery type of lithium ion, you can go ahead and use this for making future predictions. So the results that we got were pretty promising. So for 75% of the systems of the battery types that we tested, ARIMA model performed best in tracking the overall behavior of the model. We found that the univariate LSTM model is better in comparison to the multivariate LSTM model. The ARIMA model performs 1.93 times better in comparison to LSTM, and the RMSE of ARIMA is pretty good. It's between 0 to 1 for majority of the predictions that we see. So a key observation that we found that the ARIMA model, despite the absence of clear seasonal patterns, demonstrated accurate prediction, highlighting its suitability for forecasting in scenarios with limited prior information available about these lithium-ion batteries. So over here, we have just taken the screenshot of two lithium-ion battery types forecasts. So over here, if you see the first one on the left-hand side, so on the x-axis, you'll see the charging files. So basically, as I mentioned, for each battery type, we have many files, right? So for each of those files, we have calculated the RMSE for that file based on the forecast, and we have plotted it over here. So if you see this graph, that the RMSE of ARIMA overall is the lowest for all the charging files. And similarly, in this case as well, if we see that for majority of those files, RMSE is between 0.5 and 1, and it's the lowest overall in comparison to the univariate LSTM and the multivariate LSTM that we see. So the challenges we faced is, first of all, the short time series length, right? So by short, I mean here that the 6 seconds granularity that we had in our data set. So short time series length and second level observations may obscure the seasonality, posing a challenge to model accuracy. And addressing this requires a longer time series dataset to enhance forecasting precision, particularly critical in battery-related studies. So the limitation of multivariate LSTM is pretty clear. So we need the other independent variable value as well in the future. So this constraint underscores the need for comprehensive data availability for robust forecasting when it comes to multivariate. So we can basically rule that out. Then considerations for effective forecasting. So balanced data, feature engineering, and domain expertise to deal with the battery types, right, are pivotal for maximizing the effectiveness of diverse battery data sets in forecasting. So effective pre-processing and feature engineering tailored to the domain-specific characteristics of each battery type are essential for the model efficacy. And obviously the impact of data side, as we mentioned. So if you have a larger data set, then LSTM might be able to perform better on the for forecasting. So practical implications, right? Where can we utilize this
Excuse
when?
me, sir. Really sorry to disturb you, but I'd like to remind you of the time limit.
Yeah, Ishita, thank you. So the practical implications where we can use this methodology, right? So grid integration for renewable energy. So temperature forecasts aid in optimizing the energy discharge and charge schedules in these storage systems when it comes to grid renewable energy. And aligning energy usage with temperature conditions maximizes utilization for stored energy, improving grid stability and reliability. So if we are able to get this, if we are able to observe the trend of this temperature, right, during its charging phase, we can possibly improve the stability and reliability. And then the other practical implication could be thermal stress to prevent that. So forecasting temperature fluctuations enables gradual adjustments in battery operation to mitigate thermal stress, prolonging battery lifespan. So this is particularly crucial in applications like electric vehicles and portable electronics, where rapid temperature changes can impact battery performance and durability. And lithium-ion batteries are the most widely used batteries in electronic appliances overall, right? So the conclusion, right? We have demonstrated the relevance of time series forecasting models to be able to work on battery data sets to be able to get a concise prediction of these battery temperatures, right, for different battery types. And we have tried to proposed a method to generalize a forecasting model for each battery type. And the main challenge which we like to highlight is the data quality, right? And a domain expertise would be crucial when it comes to feature engineering of this data. So yeah, that's all. Thank you, everybody. I'd be happy to take any questions.
All right, Utkarsh. So it's a wonderful work, I must say. The only complaint regarding your presentation is the size, font size. I was really
Oh,
struggling
sorry.
zooming in and zooming out all the time. So I could hardly see anything on the screen, but you presented it well. And interestingly, you covered all the aspects which usually people miss on. Let's say if we talk about limitations or, talking
Right.
about the challenges, and everything was considered in a wonderful manner. The only part where I would like to give you suggestion is
Yeah.
including more research papers, right? You took just 2 papers for
Yeah. So
your.
Dr. Neha, that was for the presentation. We have referred 6 papers in total. So for the
All right.
presentation, I thought maybe just show 2 of them instead of populating the slide.
No, but that is required,
Okay.
right? So
Right.
in fact, we take into consideration at least 10 papers or more than 10 even. So
Okay.
they give us a good comparative analysis of
Right.
whatever is pre-existing, and what were the challenges or limitations of the previous work done, or what ignited the new thought
Right.
in us to take up our work. So that is I would say the highlight of any presentation,
Right.
that what motivated us to take up our work.
Right.
So yeah, that was like missing in this. Otherwise, it was a really perfect presentation, I would say. Thank
Right.
you.
Makes sense. Thank you, Dr. Neha. Thank you.
So Mahmood, would you like to ask any question?
Okay, I have a questions to presenter. Can you open please your PPT again?
Yeah, sure.
Okay, please share your screen. Okay, go to your dataset part.
Right.
Mm,
Sorry. My screen is still visible, right?
No, it's not visible to us.
You can share it again, once again. Yeah, it's visible now.
Yeah, sorry. Yeah.
Okay. So where from you have collected this dataset?
So this, as I mentioned, we have got it from the Center of Advanced Life Cycle Engineering. So CALC. I can share it with you guys. And
So this is the repository for the battery, right? This is
yeah, that's the repository for the battery. And some manufacturer had uploaded that data over there from which we have taken. It's the same data which you can find it's available on the NASA dataset portal as well. The same data.
Mm, okay, so I've seen that you have applied the LSTM as a classifier. So have why you have not applied or considered the other deep learning classifier instead of LSTM?
Yeah, so the most majorly used models on our research we found were, as I mentioned, were ARIMA, LSTM. Then there's Profit model of this Profit, and there's Sarimax, Sarima model, and there's Holt Clevers method, right? So these other models, they also take into consideration the seasonality present in the data and are good models for forecasting when there is inherent seasonality already present in your data set, in your data, right? In your time series data. But what we found from our analysis of our data set that we had in hand, right, is that there was no seasonality present in the first place. So that
Okay,
was
the
the reason why,
reason behind to select LSTM for the time series data, right? Because your data is the time series and the
yeah,
LSTM is the most suitable for the time series data.
right,
So this is the main reason, right?
right.
Okay, go to the your method part. I can go. Methodology. So why is your the method diagram? And is there any diagrams to the or flow chart?
Oh, for you're saying for LSTM, is it?
Yes, maybe LSTM or maybe the framework or
Well,
structure of
this
your
is,
work is okay. Maybe this one is the flow
yeah,
chart, right? The proposed
right.
methodology. Okay, I'm not seeing this. So can you make it zoom?
Yeah, sure.
Is it's not clear to me.
Is it visible now?
Yeah, it's right. It's visible to better. Okay. So I can see the another model here named ARIMA model,
Yeah, ARIMA
right?
model, right. Yeah.
So is the model the same as LSTM or
No, it's different. So so LSTM, in what LSTM does, it trains the model on sequential data, right? So let's say we have data for 1 month, and the window size we have taken is 7 days, suppose. So what LSTM does is that based on the first 7 days, it predicts the value of the eighth day. Then what it does, it takes the previous seven value from that eighth date. So basically, that would mean it would take the value from the first day to the eighth day, and then using that, it would predict the ninth day. So basically, that is what LSTM does, sequential data. And opposed to that, what ARIMA does is it has three components to it: autoregressive, integrated, and moving average. So basically, what it does, it takes into consideration the previous time step which had the greatest correlation to the current time
Okay,
step.
so you are making comparisons between two models,
Yeah.
RMI and the LSTMs.
LSTM, I'm making comparisons between the two model, and whichever model would give the least RMSE, that would imply that that model has been able to track the behavior of the temperature or the metric in consideration best, and we can go ahead in forecasting the value with that
It's okay.
respective model.
It's okay for my side. Okay, thank you.
Oh, thank you.
Thank you, sir. We'll be proceeding with our next presenter. I'd like to once again ask for Sir Carlos. If you're here, then you can start your presentation. Sir Carlos. Seems he's not here. Then Sir Lassen, if you're here, then you can start your presentation. I'd like to ask the chair if, since we do not have our two presenters, can we move on and take up Diana, because she couldn't join in the last session?
Okay, please.
Share my screen.
Sure. Diana, you can go ahead.
Okay. Okay, do you see my screen?
Yes, it is visible.
Okay, great. Okay, impact of just a moment. Impact of artificial intelligence and human factors in hybrid intelligent dentistry with my team Тихомир Добромаджиев, Dimo Doskov, Ivan Pev, Nikolai Mirchev, Rosalina Dimova, and Yulia Radio. We work with for this problem. I'm Diana Popova. I work at Dental Prime Dental Clinic, and I'm PhD student in Technical University of Varna. I will present this problem with the paper. The field of dentistry is being transformed by the integration of AI, artificial intelligence, and careful consideration of human factors, resulting in the emergence of hybrid intelligent dentistry. This article explores the profound impact of AI and human factors in the context of dentistry, emphasizing the synergy between technological advance and human experts. The article examination how AI-driven tools and algorithms are improving diagnosis, treatment planning, and patient care. We are addressing the ethical, regulatory, and practical aspect of implementing these technologies. It's also examination the role of dental professional and realizing the full potential of hybrid intelligent dentistry, highlighting the need for a collaborative approach. Introduction, the article seeks to explore the multi-phase dimension of heat shading, white in the profound of implication of dentistry and present real-world example from dental practice, where AI application and the human factors are converged to create sustainable treatment and deeper and understanding of dental topsy in the context of Industry 5. This transformation is catalyzed by the synergistic fusion of artificial intelligence and the nuanced consideration of human factors, culmination in the emergence of hybrid intelligent dentistry hit, unmarked by the high progression of technological innovation. The dental profession stands in the practice of the new lifestyle, one of which of the collaboration of AI and human expertise promise the redefine the very nature of dental practices, associate advance into an Industry 5 and Society 5.1 characteristic by
interrupt, Diana. I can't. I'm so sorry to interrupt you in between. I can't see the slides changing at all. Kindly put it in slideshow mode.
Okay, just a moment. Do you see now?
Please
Do you
run
see
it.
this?
Yes.
Impact of okay. Impact of artificial intelligence and human factors. And And human factors inhibit intelligent dentistry, strength and weakness. Strength, first point, it enhance diagnostic and treatment planning, augmentation of human expertise, second point, third point, efficiency and work for optimization. Weakness is ethical dimension and data privacy.
Please run your
Regulatory
presentation in
hurdles.
slideshow mode. Dinah, please run your presentation in slideshow mode. Press
Show
F5.
mode.
Yes, press F5.
Press. Okay, just a moment. I will. But it's not working.
It's in the right side of the
Yes, but it's not working. Clinical example from the practice. Using DiagnoCut in dentistry related to the human factors. DiagnoCut is powerful. Do you see now?
That's okay. You can go on. Yeah.
Okay. DiagnoCut, AI-powered image analysis. DiagnoCut leverages advanced AI algorithms to automatically analyze dental image. It can detect and highlight various dental conditions, providing rapid and accurate assessments. Automation, the software significantly reduces the time required for the image analysis, allowing for a quick and efficient evaluation of patient image. It can generate reports with finding in matter of seconds or minutes, and human factors, user-centered human factors principle are essential in design user-friendly interface for software like DiagnoCut. The goal is to create an interface that is intuitive and efficient for the dental professional to use. Usability testing, expert of conduct usability testing. The software use interface intuitive and meets the need. And this is dentistry example, clinical case 1, figure 1, show tooth 23, root stop percent is good, canal stop percent and filling 98% tooth. This is diagram for every different tooth. What is the health of this tooth? This is clinical case 2, include again eye orthodontic screening with following result: tooth 13, tooth 12, tooth 11. Explain different percent of the problem of this tooth, and explain to the doctor what need to do. Dentistry example, clinical case 3 include again eye orthodontic screening with following result. Here we have only tooth 7 with the problem, and result and discuss the synergy between DiagnoCut AI and human factors in the context of hybrid intelligent result is improved dental diagnostic and patient care. AI enhance efficiency and accuracy while human expertise ensure that the patient care remains personalized, comprehensive, and safe. The cooperation is essential in achieving the best outcome in the field of dentistry. The importance of hybrid intelligent dentistry is this case wise the cooperative effort between AI and human expert. 3-point accuracy, patient centered care, and quality assurance. Human oversight ensure that I generate report and accuracy that any knows the complex case and approve. Conclusion, the synergy of artificial intelligence and human factors in hybrid intelligence hold immense significance, particularly in the realms of dentistry and healthcare. This powerful cooperation harnesses AI computer powers and understanding of human interaction with technology. In dentistry and healthcare, hybrid intelligence is the key of the uncloaking transformative advancement, providing more efficient and patient care. And the ethical standard and the bridges of the gap between human expertise and AI capabilities, promising a more clear future for healthcare and dental practice. How this good practice can be concluded as AI operation, human-centered design, transforming patient care, ethical consideration, safety, and reliability. I say my acknowledgement to Erasmus project cooperation partnership in higher education project title Ergo Design Improving Digital Skills for Ergonomics and Bioengineering Innovation for Inclusive Healthcare, Ergonomics and Human Factors Regional Education CIPS Network, Bulgarian Association of Ergonomics and Human Factors, and Enterprise Dental Clinic Bulgaria and London. Reference, and thank you for your attention. I was Diana Pavlova.
Ma'am Neha, would you like to ask any question?
Yeah, thank you.
No questions from my end.
Sir Mahmood?
No question from my side.
Okay. I'd once again like to ask for paper presenter Carlos. Alassane, if you're here, then you can start your presentation.
Can we move to the next presentation, please?
Ma'am, they are not here. This brings us to the closing. I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. On behalf of the whole team, thank you for your support during the ninth version of the conference and all the previous 8 versions. We will be happy to have you in the 10th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months, so kindly cooperate with the team of ICICT 2024. I also would like to thank our session chairs. I'd like to thank Dr. Neha Tiwari for chairing the session. A token of appreciation to the chair on behalf of Team ICICT 2024 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, ma'am.
Thanks a lot.
I'd like to thank Professor S.M. Hassan Mahmood for chairing the session. Thank you for your valuable presence, sir. This brings us to the end of the conference. I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.